Um, let's go ahead and get started for the folks who did get here in time. All right. And we got John here. Let me just. How you doing, John?
Hey Tom, this is John. Yep.
Okay, great. You got your hand up. Didn't know if you had a question or not. I'm going to go ahead and mute you back down. Did you
Oh,
have a
good.
question
Okay.
or anything you want to share?
Nope. I'm sorry. I just forgot to lower it.
No worries. And I could have lowered it too for you. Sorry. All right. Got a big turnout tonight. And I've got a lot of poll questions we're going to be going through to help me figure out and help all of us actually figure out the best nights to have our webinars and the best times and kind of introduce everything that's going on here, okay? So those people that are coming in, I am just saying again that we're recording these. All right? Now, let's go ahead here. One poll question should have probably asked right off the bat is, and I can just make a note of this one, how many of you are teachers? Raise your hand if you're a teacher, you're a coach, you're an instructor. Okay. So I've got, this will be classic. All right, I'm going to put everybody's hands down. How many of you are students? How many of you, raise your hand if you're a student? Well, folks, we have about equal of each. You know, we got about, it's a slightly more now. Someone put a hand up there. I can't decide if there's a teacher and a student. But we have about 60% students. We are 40% or so teachers. Okay, thank you. I'm just going to make a note. I have poll questions for the other things. We're going to get started real quickly on this. I just need to, so I know what the model here. 60%, 40. All right. How many of you have a kit with you or have an Arduino and the electronics with you? It is not a game breaker if you don't have it. But if you do, raise your hand so I get a sense of that. All right, that's about a third of us. Okay. And I promise you, we're just doing some of these polls, and then we're going to really get started. We're not doing the whole nine part. Here's one I'm going to just put up so I can keep a record of. I'm going to launch this poll real quick. If we can go ahead and answer these questions, that would be great. How many of you, go ahead and vote in this poll. What nights work best for you? Now, this is somewhat self-selected that we had this on a Wednesday night, and I'm asking this. The people that Wednesday night works would have done it. But give me some different days. You can vote more than once on this. You can vote on more than one day if you'd like. So I get a sense of what days are going to work really well for us. I see Wednesday's a pretty good night here. All right, we got 92% voted. 5, 4, 3, 2, 1. Going to close it at that point. I always share results on polls. It looks to me like Wednesday's a pretty strong night. All right. You know, say I put Friday or Saturday, so we didn't do that. All right. Let me go hide that results. Another quick poll. What times work best for you? Okay. 100% voted. All right, close the poll, share results. Wow, 7 o'clock to 8 and 8 to 9 seem to work really well. Okay, 23% there. Okay. And this is helpful for me for recording these. Can you watch these on YouTube if they're recorded? This should say if it was recorded, can you watch them on YouTube? This is real helpful for me, for the teachers, if they want to show it in their classroom too. And you can write a question. You see you've got the little hand mark. There's also a place to write questions or comments. You can always send them to me there. I'll also put my email out. So if you want to add some things, go ahead. All right, we're at 92% voted. 5. I'm going to count down and I just close the vote. 100% voted. Okay, close the poll, share results. Most people can see it on YouTube. Great. 23% aren't sure. That'll help me decide. Then we will post it up here. A little bit of sense of humor on this one, but this will also help me on getting the word out. What social media do you prefer? right, and you can do more than one if you like, but good old email being very strong here. I'm going to close the poll, share results. Good old email, good. Some people like Instagram, okay. Well, I'll be able to do Instagram more. I think once at the competition, we can take some pictures. All right, next question. I'm asking lots of questions here, but this really will help us out. How many of you have you used an Arduino before? All right, here we go. Close the poll, share results. 8% said, yeah, I've used it. 85% said, no. And 8% said, what's an Arduino? All right. That pretty much represents that what's an Arduino's kind of answer I gave in school a lot. Like, what are we talking about? All right, let me have this. How many of you Scratch? All right. And it gives you an idea. Most people have not. That's fine. This is any of the text-based languages: C, Java, Python, Java, any of the languages. All right. 3, 2, 1. Let's poll share. So we got half the folks, slightly more than half, have done some programming. 33% said no, not even a text-based, and 8% said maybe. Okay. Last one, and then I'm going to stop with these annoying polls. How many people have used 123D circuit? And I seriously understand if you've not, but this is out. This is our last poll question. All right, great. 93%. I'm going to go ahead and close the poll. Share results. 86% said no. 14% not so sure. All right. This will help me as we plan this. We have more folks coming in. All right, here's another question. Let me get this question behind us here. Someone said basic. Yeah, basic's fine. It's a text-based language. I just kind of get a sense of where we are on languages. Okay, great. So, got slightly more than students here than teachers, and we have a third of it kits. The 123D circuit will be one way for us to do this as well, even if you don't have electronics kit at home. The other idea is if you can access YouTube at school, you'll be able to do this at school as well. All right? And we might be able to figure out a day that we can actually do lessons at school if I get a real tremendous response that people would like to do it. Okay. This is going to be Arduino basics to get us ready for amazing mechatronics. If you know this, I've got Arduino's basics instruction. I don't have amazing mechatronics up there. It's because I teach a lot of folks how to use Arduinos. And so we're using some lesson plans that work, folks. So you can feel pretty good about that. If you've done programming, you know we have a tradition as programmers to make Hello World to start our first program. Well, we're going to do a blinking LED. That is the equivalent in the embedded computing or physical computing world. We're going to talk about what those mean here in a second. Okay? Before we go any further, though, I just also want to point out, if you've got a question, just raise your hand. Click on the little hand. It'll pop up. Okay? Now, just a little bit about me. Oh, we got a question already. Good deal. Will we be allowed to use any language you want to program? Hayden, no. You'll have to, unfortunately, you're going to need to use the Arduino language. It's called Sketch. It's a lot like C. You'll have no problem. All right? So, because it's a competition, I've got to be fair to everybody. We're going to use the one language on that. All right? And that comes as the default language. I hope you appreciate that. Is that okay, Hayden? I'm trying to catch you. I can't hear him, so probably doesn't have audio. All right. Now, I came out of college. I was a chemist at a time when computers were just starting to come to the workplace. Started doing programming, then ended up teaching. Started teaching, I thought, for a couple years, and 27 years later, I'm still a very active teacher. I've been teaching engineering, or what they call STEM, for 25 years, last 25 years. I'm also doing enrichment classes across the state of North Carolina, Iowa, and actually parts of the U.S. Young engineers of today, involved with Gamma and aviation competition, if anybody's interested in that later for their schools. We get them free software and the whole 9 yards. Also, very fortunate that I got to know the good folks at Science House, and that's how I got to know Kim. And I'm in the past, I don't have it listed here, was involved with coaching and doing Science Olympiad quite a bit. And I'm involved with the maker community. But I guess what really pertains to what we're doing tonight is you can either thank me or fuss at me. I'm working on the Amazing Mechatronics contest here. And I'm writing up the lessons that you're seeing now and the challenges. But I can tell intimately we wanted to do this. We wanted you all to be exposed to microcontrollers, mechatronics, combination of mechanical, electrical, engineering, and programming. When you do robots, which I know are very popular right now, and I'm on the first LEGO League commission and done a lot of that first and all those other things. But when you do robotics, you're doing mechatronics. But mechatronics is a lot more than robotics, and there are great career possibilities there. And so it's also a way of doing mechatronics was a way to do robotics a little bit cheaper. If you've got go out and buy kits, they're expensive and they're lots. What we can teach you here can show you how to make your own robots, a lot less money. This fall we were making pumpkin robots at my school and with young engineers today. But this will give you an opportunity to apply that. If you are in first or stuff, it'll also improve your skills. But mainly, it's going to help you with the Science Olympiad. It's a trial event, and but we're investigating this for down the road. So we'll see how it goes and see how much people like it. Now, what in the world is an Arduino? And folks, I don't blow this up to full scale often because I've got to look on the right to see on the GoToWebinar panel. I will blow it up from time to time, but for right now, we're not going to. What can we do with it and how we control it? All right. And the answer to that is an Arduino is an open source microcontroller, which is just saying as a little computer, we can stick in other things. And they're all the rage now. You can do so many things with them. So here's the Breadboard that you've gotten, but you might have the classic, you could use a classic Uno Arduino is one you might recognize. So those are, Intel combines an Arduino onto a board they have. Here's a smaller world. You can make them sewable. There's Arduino microcontrollers the size of my thumb. Okay? So they're all out there. They're all available. And once you start to learn how to do that, you can connect your house to the internet. You can do all kinds of things. You can make your own quadcopter, your own 3D printer. Those all use microcontrollers. They have microcontrollers for little bits. If you've ever seen those. So microcontrollers really are used in a lot of the technology we take for granted today. So that's another good thing to get out of this, besides the exciting fun of being at the Science Olympiad. All right. So let's talk about the Arduino hardware, and then a little bit of electronics review, and Arduino software, and programming a blinking LED. Realistically, are we going to get through all that tonight? I don't know. We'll see how the pacing goes. If I start picking up too fast for you, raise your hand. I'll also poll you on that, but I really just stop and interrupt me whenever you can, okay? Whenever you want. All right, so this is the older kit. I'm waiting on my newer kit to come in. But you can still see in your kit, you get many of the same things that we have right here. All right, and you've got some additional things that come with the kit. But for right now, and so the big thing I want you to know is you got that Breadboard, and that's basically your Arduino, and you have a Breadboard. And in fact, they're selling these kits now. I see that they don't come with the Breadboard anymore. It has everything but it, and you just use a standard Arduino. Now, whether it's a Breadboard Arduino or an Uno Arduino, whatever kind of Arduino, here's kind of the layout we're going to see on our Arduinos. So let me take one quick minute And if you've got your Breadboard with you, go ahead and pull it out. Raise your hand once you have it out. And I know a lot of people don't even have one. So go ahead, raise your hand if you don't have one. So we're not waiting for somebody who doesn't have one. And then raise your hand once you have it out. So that way I know to go ahead and proceed. Once I get probably close to 80%, I usually go ahead and go forward. All right, so go ahead and get it out. That way you can look at it. And if you don't have it, don't worry. I've got some nice graphics here to show you. Okay, good. We're going to go ahead here. So here it is. Here's a power jack. You can hook it up to this right off your computer. It uses your Breadboard uses a mini USB cable. The old Arduino, if you've got a green Arduino, they use their standard printer cable, USB printer cable. But you use a mini on this Breadboard, and you use this power jack. So you can get power either through your computer or you can put a 9-volt battery and plug it in there. I would not plug anything more than really a 9-volt. Technically, you're supposed to be able to do 12. This says 15 volts. I usually keep it to 9 volts. I want to fry mine. All right. Here's the USB. And there's the little USB-B mini. Here are the power pins. If you look to your right, it's got 3 volts, 5 volts, and a ground. All right. Just a quick reminder on electricity, folks. If what moves voltage is a difference in potential. So, literally, you have 3.3 volts and you're going to connect to the ground. The current is going to go downhill, as it were, from 3.3 volts to the ground for things we're talking about in this class, okay? For generalities. Just think of that. You've got a potential difference there, 3.3 or 5, going down to ground, which is basically 0, okay, which literally means ground. All right? So right there, if we just need to power it, and in the beginning, we're going to power an LED. We're just going to turn it on and off. Well, you don't need to use any of these other pins. You just use the 3.3 volts and the ground, and we can power it. But pardon the pun there, what makes a Arduino's microcontroller so powerful is the pins. You've got analog pins, which give us a range of values. Then you have digital pins. Digital's on or off, yes or no, true or false. Analog is, think temperature. There's a whole range. Okay? By the way, in this microcontroller, there's all kinds of different microcontrollers, PICs, I can't think of the other one that was real famous too before that. Basic stamps, those things. The open source, they drove the price down and they made it very available, and it really took off. A couple college students designed this, graduate students, and designed the original Arduino. It's just a side note. All right, there's your reset button on yours. Now, the point of the amazing Mechatronics isn't to teach you necessarily the Breadboard Arduino. It's to teach you a little bit about microcontrollers and programming. But even more than that, it's to teach you the engineering method. It's to teach you how to problem solve. So right there, as you go through this, we're going to test you in the actual contest. And we'll get that down the road. Let's not worry about the contest right tonight. But what you're going to do in the contest, troubleshooting is going to be an important part of this. Plus, and I'm directing this to the students here, not to drive your teacher crazy and frustrate you, we want you to learn how to troubleshoot it yourself. Okay? And so one thing we're going to be looking for on this is lights. We use LEDs quite a bit as to tell us if things are working on our electronics or not. So electronics is one of those great things. It's almost magical. You can only see the results of it. You can't see the electrons moving around. So one thing we look for, you see these lights? That's a TX, that's a transmitting light. All right? There's the receiving light. When our Arduino receives something, this is when our Arduino is sending something. And when we first turn it on, we upload and download our program, those lights are going to flicker like crazy. And then pin 13 is a little LED for us to test out ideas. and it's right there. We want to use that for just turning it on, blinking things. We normally don't run pins into there. That's the equivalent of this. See, there's a resistor. This represents pin 13 connected to an LED. That's what that light is for. Generally don't use pin 13 for everything else we're doing. Okay? Got a question? Excellent. Let's see what the question is. Okay, how similar is to a board of education? Very nice. Thank you, Luke. Very nice. Oh, goodness. All right. Now. Okay. I'm assuming you're making a joke about school boards, but there may be a microcontroller out there called Board of Education, which would be a clever name for a board. If it is, let me know. All right, now, there's the power on LED. This is probably the most important thing. When you plug your down the road as much as you can, I hope you've got your Breadboard running, and we'll run these programs while we're watching them. Let me see. It's a real thing. That is a great name for a board, Luke. I'll look that up, or if you can send me a link later, that is awesome. If it's Arduino compatible, it's very similar. Okay, generally, but I'd have to see it. What a great name for a board. Oh man, learn something new every day. All right, here we go. So this is a power light. So when you go to troubleshoot it, you plug it in, that light comes on, but it never transmits, then you know you got a problem uploading and downloading programs. If that light isn't even on, then you know, well, your program's not going to run there, and your circuit's not going to work because you don't even have power to it. So you got to figure out why you don't have power to it. So we're going to use those lights. Okay? So real quick question. What is 8? What is 8? Think about this. I'll go ahead and go on. It's an analog input pin. So these are all inputs right there. Okay? 4, 5, and 6. And these lights right there. Well, 4 is TX, 5 is RX, 13 is LED. So what do those mean? I'll give you a second. Let me go ahead and answer this, and I'm going to answer your question. No, it's just a real quick way. It's not an error pin, I don't believe. But let me get to Hayden's question in a second. But 4, 5, and 6, that's going to be transmitting, receiving, and the pin 13 LED. Now, Hayden just asked a great question. Would the primary function pin 13 be an error lead? Like put your code in, try a loop, and turn on the LED if the code raises an error. Sorry for being a little late. Don't worry about being late. Second of all, it's a good way to test if your code's working. So yeah, if you're trying it out, yeah, pin 13 is great, especially when you don't want to have to take the time to hook up an LED to test it out. So if you're talking about it, yes, for troubleshooting. Oh, okay, a parallax. There it is. Parallax is different Arduino, but it works. It has the same kinds of functions. All right. I don't use a lot with parallax. I got started on Arduinos. There's other people I've used parallaxes their whole life, and it's awesome. Okay, so we have different pins that we go on here. 9 is the on and off switch. The chip really of this AMR chip is right here. That's the chip that really runs everything. We don't right above this 4, 5, and 6. Analog input is right here. We're going to come back to that later. This is where your power goes again. So we talked about that. All right. Okay. Real quick, just raise your hand. I'll hit again. How's the pacing, folks? Are you good with the pacing? Raise your hand if you're good with the pacing. Okay. All right. We got about 71% saying it's all right. Okay, I'll put everybody's hands down. So we'll keep it at this, and I'll ask a more formal one here in a minute. Okay, here are breadboards. And many of you have had breadboards probably in class, but in case you didn't, or maybe they spent one day on breadboards and they expect you to remember it. We're going to go back through this. If I could peel back the breadboard, you'd see these little middle clips. And so when your LED goes in there, it snaps in there. All right? Let me see if I have a question here. Yeah, Brian. You got a question? Hey, Brian Harris. Okay, I'm going to mute him back off. If you question, write it in there, but I wasn't able to hear you on that. If you can get your mics and everything set up too, it's great because we can go a little bit faster if you can just say it. But if you want to write it, you might have just left your question. I'm going to put your hand down. Let me see if we can get them here. All right, now. That's how an LED goes in. It snaps in there. So you see these rows? Notice though they're going there. This row, if you look at where my mouse is, everybody look at my mouse. Come down here. Notice this row is going vertical, and these are going horizontal, and they're separated in that center channel. All right, what I want you to realize as you go to wire in a breadboard, they're numbered in rows, and there's the columns. That we know. But these buses on the outside, they go in the vertical. So if you connect something here, it's connected to something right up here in that. Horizontally, this way. And 21 on this side does not connect to 21 on that side. You're going to see this all in a few minutes when we go to 1, 2, 3 circuit. So this gives you another sense of this. Positive rail here, negative. Assuming you plug in to the red rail, your hot, your 3.3 or your 5 volt. And that's what we're going to be using, folks. So you don't have to worry about electrocuting yourself. Teachers, don't worry. We're not going to do anything to get them. That blue is your ground. And then they're connected this way. You can see it right here. All right? And this decides, restricts electricity on either side as we get to do this. Okay? Now, and right now, this is actually out of 1, 2, 3D circuit. And I'm going to show you it, and then we're going to want you to, down the road, get everybody on it, because 1, 2, 3D circuit is a great way to simulate electronics and Arduinos. So people can try this stuff even if they don't have the Arduino. For teachers, if you want to do this with your class, you could do this. You wouldn't have to have a room full of Arduinos right off the bat. Ultimately, you want to get Arduinos. It's, you know, an LED flashing in a simulation is not the LED flashing in real life. But when you don't have anything else, it definitely is a much step up. So here we go. Let's talk about placement of components. Again, you may have used a breadboard and say, I've already done this. But for people who not, or it's a good reminder, because you're going to be troubleshooting and you want to do silly things. Remember we said the power rail goes all the way up here? So in the vertical power rails, on these bus rails, we want to go horizontally. And on the horizontal rails, or horizontals, we want to be going vertically. So let me show you. So in this case, this is the right way to hook up a resistor. But if you hook up a resistor vertically like this, it's not going to work. And it's not going to work because electricity always goes the path of least resistance. Water always rolls down a hill. All right? All right, John's got a comment here. Yeah, John.
You do not seem to have in your correct one a good LED one up there on the power rails. It's fine if the LED can handle the voltages you have on there, but if you put in, say, a LED that requires 1.5 volts and you got 5 volts on there, you're likely to just see a big flash.
I understand, but I'm not. All we're worrying about is placement right now. But you're absolutely right. You'd want to put a resistor through there. You're correct. You're absolutely correct. If what John is making a very, very good point. Whenever we hook up an LED, you better be thinking is, where is the resistor? All right? So John's making a great point that, hey, if you hooked up that one LED under correct there on the rail right here without a resistor, it would fry, especially a red LED, if we had it hooked up to 3 or 5 volts. All right. Is something else you want to add to that, John, so I can share with everybody?
No, it's just a common error for people that are just starting, and I wanted to make sure people wouldn't try something like that.
Yep. Good point. All right. Um, I'm going to go ahead and mute John right there just so we go on here. So with John, so here's what I was going to try to say is here's would be the correct way to hook something up. You're coming off of ground to that resistor. Notice it's parallel then with the LED right here. See how this leg is with this leg, and then the longer leg, demonstrated by that little bend there, goes back out on the positive rail. LEDs have absolute polarity, so we want to make sure that's one thing we got to be careful on our polarity. But let's go back to what I was going to say over here. If you put this resistor in, or this LED in this case, what's going to happen is the current is not going to go through the resistor. It's going to go underneath it, under that rail. So it really doesn't do you much good. So you want to, if you're going vertically, you want to put your components in horizontally. And that's all I was trying to demonstrate this. This wasn't not meant to be live. All right. So in this position, it wouldn't work because the current goes from here over to here. So this resistor would just be ignored. Okay. All right, so there we've got our circuit. There's our ground and our whole roll. So just remember that if you're using this rail up here, you're going to want to go horizontal with it. If you're using this rail, you want to be vertical. So in this complete circuit, as John pointed out with the resistor, we want to take ground to here. So this leg of this is on the same row with this. Just assume this blue and red rail have power to them. So there's your ground to here. Or we could do it from the hot side if you want to say this is 3.3 volts. Go from here to this row, longest leg going to the LED, then over to here to the short leg, going to a resistor. They're on the same row, and then from the resistor back to the ground. You're in effect forcing the electricity through those. Okay? All right. Now, when we talk about LEDs, we're talking about the anode, cathode, and just say the positive and the negative. Not going to get torn up about what it is. There's pin 13 on our LED going through a LED. By definition, diodes are very much sensitive to polarity. You know, if we had time, we would do labs where we could just demonstrate this over and over again. And then you have a resistor, 330 ohm, orange, brown, and you'll match it up that way. A tip for me, I don't know what others think on this, but in class, I almost always insist kids pull out multimeters. All right? That's just another way to check. Now, in terms of the resistant, block is, I don't like the term block there, but reduces current. So here you've got pin 13 LED with a resistor and a ground. A resistor does not, but I really want you to get out of this. The LED has direction. A resistor doesn't. You can put it on in either direction, and it's not sensitive to polarity. Okay. This is another old school symbol of what the LED would look like. Here's your battery. Here's your resistor, and you complete a circuit. You go from. In reality, since we got everybody here real quick, and I think John will appreciate this too, we draw current going positive to negative. In reality, it's the opposite. Electrons move, the protons don't go anywhere. So, but they started it that way, and they've just kind of agreed to that standard. So in any case, here is our LED to a resistor to a battery. All right? Now, what we are also going to use, and it's a great program, now, this is one of these programs that's free, and they keep improving it. It's done by 123D AutoCAD, so there's a real commitment, a lot of money behind it, so I'm feeling really pretty good they're going to do it. Now, to use this program, and I want you all, we're going to try this now, is you're going to need to be using Chrome. All right? And for some folks, you don't have Chrome, you can't install it now. I believe also, I'm a Mac guy, so Safari doesn't run well on it. Use Chrome. I believe Internet Explorer works well with this. I don't want to spend very long trying to install it. It's a web browser program, so you don't have to really necessarily install it. But if there's an issue, I'll stay after and help you. I don't want to tie us all up on this. But what you would do is go out there and just do 123D circuit. So if you search it, 123D circuit, and I'm in Chrome right now. Let's go ahead and pull this up because you'll find this useful. All right. You'll see a screen something like this. You launch it online. You may need to join it. Again, it's free. Don't do the paid version. There's no reason for it. All right. I'm already a member on it, so I just popped right in on this. And then we're going to go to New Board and Circuit. All right. This will allow you to make PCD boards. Circuit Scribe, we're not really even using that. That's the pen that you can draw things on. So it looks something like this. And it'll pull it up. While it does that, I'm going to go back to our screen here. So you're going to select New Breadboard and Circuit, and you want to get to this thing right here, Code Editor, Components, Start Simulation. All right, let's take a couple moments and see if we can get people on this. This will allow us to do some of this programming and stuff even if you don't have the hardware with you. Okay? Raise your hand once you've gotten it. All right, let me get Bailey here. Oh, wait a minute. I'm going to mute him. Just raise your hand once you've got it so that way we know. And while you're doing that too, I also want to make sure everybody understands Amazing Mechatronics, any of this stuff doesn't happen with lots of other people's help too. So it's not just me working on this. But I do, if you got questions or stuff, go ahead and send them to me, and I can be the guy that gets fussed at. We got about half of us now that have it. Remember, and it's easy to forget, raise your hand once you have it. So that way we can start moving on. All right, we're getting most everybody's getting on there. If you're not going to go on it, or you're raise your hand as well, so we're not waiting for you when you don't really have plans to using it or whatever. All right, great. Okay, excellent. So we have most folks on this. Okay, we're going to go ahead and go through it. I just want to point out a couple things as you get started on this. Here's the shortcut keys for this thing. There really isn't a lot of shortcut. There's really not a lot of keys on it. You rotate things with R. I think you're going to find that you use it. Most everything else you would be is what you would probably expect as far as like undo and deleting elements on this. And then they have these choices in here: code editor, components, start simulation. Well, you can imagine we're going to start with components first. I'm going to put everybody's hands down now. And then we can start the simulation when we want to have it. Code editors when we've hooked up an Arduino to it and we really start programming it. All right. So let's go down here. So it'll change color and you can flip it. I'm doing it this way, and then you guys can all try it and I'll show it on there, but this way it's a little bit quicker. So you're going to get a breadboard, you're going to take it, hit R, and start rotating it around. It'll change colors, click on and off of it, and you'll see that it looks a little bit differently. So like this, when you haven't selected, it looks like this. And there's an Arduino. They don't have a red spark board, so just take the Uno one off that. Okay. All right, we're going to come back to that in a minute. Let me go ahead. Do the same thing on here. I probably just did it twice. So there's my unnamed circuit. There we go. So I'm using my mouse to spin it out. I'm going to click on it, change that black sign. Notice the breadboard, I got a name of it. I hit my R key, it's going to rotate me around. I'm going to shrink it, roll my mouse out, roll a little bit farther. Watch that. Escape. Command Z. You got to be careful. Sometimes if you click on one of the holes, it'll add a wire there and you don't really want it. And then if I click on components, I can go down there. And if I go down to the bottom and rotate down, I should find an Arduino. There's one right there. I'm going to take it. I've selected it. It's kind of black. I'm going to turn around with an R. Grab it and move it right up here. And then I can move in closer or farther away. Notice the Arduinos can have names on it. Okay. For those people that are doing it, well, raise your hand if you're not going to do this or you can't do it, and then raise your hand once you've gotten it done. You're trying to do it and you're waiting it, so I can wait for you to get you to this point here. Pull up a breadboard, put that in. All right, great. All right, got a question. You don't download this program. It's web-based. As of right now, that's all I'm aware of. So again, if you're clicking on this breadboard in the center where there's no little, like I said, it doesn't think you're putting, it'll change black. Notice the Uno has now got white print. If I select that, it goes to black print. If I select over there, neither one, there's no mention of the item over here. All right, if your board's not rotating, what I would do is make sure you clicked on the board and changes color like this, and then hit your R key there. Make sure breadboard should come up on the side too, and then hit the R key on that. All right, we got a couple more. Raise your hand if we can get moving on this, folks. We'll go ahead. How did I shrink the breadboard? Use my mouse. Roll your mouse backward for okay. Okay, good. Okay, that solved it. Great. We got different people. All right. Now, let's go back to what we have here. You're going to end up, in this case, all we're going to do is, in the course of these next slides, you're going to see this. We're going to change the colors. We're going to connect it up, put in a resistor, change the resistor, put an LED in there, turn on said LED. All right? That's our goal for this, for right now. So, that's where we're shooting to get. All right? We're shooting to get to this point right here. So let's go back up and what we're going to do. Notice when you drag the wire over, its chances are it's going to be red as you pull it over from here to here. So let me go ahead, if I've got one right there. So I'm going to go to here. Let me see, did I show that as 3 volts or 5 volts? I'm going to do the ground to begin with. So, let's go here. So I'm going to click on ground, and I'm going to go over to this blue rail. And of course, it came over as blue. If I want it to be black, I click on this wire. Not on the, make sure it says wire, so you got it. If you click over here by accident, it'll say the Uno. It'll click over here, it'll say breadboard. So make sure you click on the wire, and we're going to make it black for our ground. Electricity would run fine. It doesn't, to the electrons, it doesn't matter what color it is. But for us, it helps for troubleshooting to keep with some standards. Okay? So I've got a ground. Also, look on the breadboard if you all would look with me. If I click, look on any's, you see how they're green all the way up and down this? And you can check on your own. That tells you where they all connect. So you can see the vertical rail here and the horizontal rail here. Not the horizontal, the row is right here. So this better helps you understand what what things are connecting to each other. Okay. Then we're going to go we change the color to black. And then we're going to come off of 5 volts. We're going to put it in that red rail right there. So bring the other rail over and make it red if it's not red. Now, ideally, I would do ground. I connect all the ground away, but I'm purposely having you go back a little bit long, a little bit around about, so you get used to changing the color and finding the wire. All right, once you have that, raise your question. Let me know once you both have a black going over to the ground and from 5 volts to the red rail. I'll go ahead and put that one over there. Let's stay in red. There it is. I think this is actually an improvement in the program. It used to be, and that's why they keep upgrading it. When we were using it earlier this year, it would always default to black. Now it knows that I'm going to a red rail and I'm coming off 5 volts, so it's making it be red right off the bat. Which is kind of nice. It's making this blue, I'm assuming because of the blue rail right there. I made it black. All right. Raise your hand once your flow's done. All right, great. Now we're going to take, so I'm way consistent later, take another black rail from here to here, from the ground to there. Now that time it stayed red, so we're going to make that over to black. Just like that. Okay. Then pull a resistor and go from, now remember we're going to cross this rail because these are separated. Well, now we want this resistor, since it's in these rows, we want to go vertical with that resistor. We're going to take a resistor from the end and we're going to drop it right there. All right, I'm going to put everybody's hands down. I'll show you that. And then we can change the resistor. So if I go down here to my components, not surprising, the resistors are right up here. I drop it in there. Notice it says my resistance, it's at 1,000 ohms. We don't want to be at 1,000 ohms. We're going to be at 330, I believe. And it changed it to 330. Notice the reading on the resistor, even the colors on the resistor changed. Raise your hand once you have the resistor hooked up. Good job. You are a quick group here. Excellent. All right. Go ahead, raise your, once you get it, folks, we get more people adding on here. Then, these screens got somewhat bigger. We change that resistor to 330, not 330, 330,000, 330 ohms. The resistor changes color there. Then we're going to drop an LED here, and we're going to go ahead and rotate it through. Okay, I'm going to put everybody's hands down again. Then we have another question here. No. Not right now. We're not going to get into determining the resistor value per se on that, where we do the bands. We look at the bands and we can read the bands. Right at this point, I'm going to try to get to programming on it right now. Okay? And there are bands and there's ways to go ahead and read it, as you know, John. But right now, we're going to go ahead. I would like to get us to this light on, power it, and then try to program it tonight. So that's what I want to do first. Okay? Now, so we've got this. We're going to pull up our LED. We're going to drop it on there. We're going to rotate it around. That long leg, see, you got that long leg, the bent. It's important the long leg is hooked up to the positive. So I've even flipped it over so it's this way. So I have the ground, I've got my resistor going to the ground, the cathode of the LED. Then I've got the hot leg here. I'm going to go from this row over to the red right up there. So I flip that over. It's going to look like this. Raise your hand once you have that. And I bet you know what? Go ahead and figure out if you can start the simulation. Okay. Every time I move my mouse, my circuit board, and Arduino move, how can I do that? I think you're grabbing it when you're doing it. I'm not sure. Just click on things. Don't grab it and turn it. I think it may be going on there. And you can just delete it once you get it off there. All right. Once you go ahead, all right, now that once you have these things hooked up, all you have to do is hit over here. Let me go up here. Start simulation, and it should look like this. Hit start simulation, and this light should be on. Notice the Arduino will come on too, in fact. Wait a minute, let me show it. This will show on, the LED's on. You should see a difference. How'd you reverse the terminal's LED? I just returned it. Yay, Kim flipped it. You also can flip it sometimes, but if you reverse it, you can, and just move it. All right. Let me go back over here just to see how we're, just to make sure I'm getting this right here. Let's go here. I'll go here. Let's see, where's my resistor? Someone's asking a question. Let me go ahead and find that. Sorry, no, I don't want to do that. But if we were hooking this up, you would just hit R and then play with it. Okay. All right, so we have people getting lights on there. Okay. Raise your hand if you got it to work, folks. People forget because they go so involved with it and then they forget to raise their hand. So make sure you raise your hand so we know. All right. Now, here's what I would like to do next. In a perfect world, we would go ahead and you would get out your Arduino setup out of your kit. And here's your yellow LED. You could pick one 330 resistor. Here's your jump wires. It tells you where to plug it exactly into the board. We put it in. We're not going to do that now. We're going to stay on 123D circuit because of the time we have right now. But you certainly can look at these slides and you'll see exactly how to do it. And we even increase the slides on this. So off this, there's the hot line. Here's the ground. Here's resistor going to the negative leg of the LED, positive leg back. You plug this in, it should pop on. So if you've got one at home when we're done, go ahead and do that. All right, so here it is, ground. Now what we're going to do is play with this. Go ahead and move your pin. So right now, you came from the 5 volt over to your LED. Move that pin to the 13 on your 123D circuit. So in other words, delete it off the 5 volt or grab it by the very tip and put it into the 13 volt. Go ahead and do that for me now. And I'm going to try to hook mine up real quick so we can have this over here as well so I can see it. All right. Kind of messed up with mine now. Here we go. Let's move over components so I can get the LEDs. From some reason now, I can't get my LED. Let's shrink this in. There it is. Grab my LED. That, take this. Sometimes you can grab the end of this and sometimes you can't. Sometimes you're better off just doing this, deleting it. So I'm going to delete it off there. I'm going to take that from 13, I'm going to take it right over to the same line as the LED. Okay. Once you've done that, start the simulation. Once you've plugged it from 13 over, you didn't need to change the ground or anything. Just like I'm showing you right up here. It's just running. Okay? Now we've got it flashing. You got a pin 13 flashing. You can see it over here, but what does that really mean? Well, raise your hand once you have it flashing. And then I want to show you how we can change it so you can see how you can start changing the code. And now we're doing what a microcontroller does. Because right now, up to this point, you're physically plugging in the light and turning it on. And while it's always cool to turn on an LED, they call it LED sculpting. It's even cooler when you get the computer to turn it on and do it the way you want. Because then we can tie sensors to it and we can do all kinds of neat things. All right, so raise your hand once you have it. You have this up to pin 13 and start the simulation. it'll start flashing like this. Okay. All right, raise your hand once you have it. Okay, great. Got about 8% of you saying you got a flashing LED. And what's cool is, come back later, you can do this on the physical. Now, what I want you to do is go to Code Editor. Don't worry about understanding all this code right off the bat. We're not there yet to do that. But if you see it, you see a // that's a comment line. It says, pin 13 has an LED connected on most Arduino boards. We knew that. Give it a name. There it is, 13. There is output. What I want you to do is where it says, there's an all Arduino programs for the programmers here. There's always a void setup and a void loop. Void setup and a void loop. You cannot run the program without those two functions. All right, the setup and the loop. Now we're going to go down where it says display right. It says turn LED on, LED, which was 13, and we'll explain all this. Don't worry about not knowing it right now at this moment. But change that delay to 1000 to 2000. And then, once you've done that, download the code. Well, no, don't do that. Wait a minute. You can download it off there. Let's stop the simulation, and then start the simulation now. Look at your blinking. It stays on longer, doesn't it? So you can download the code if you want to save it for something else, but just hit start and then restart the simulation and it'll upload it. Right here, upload and run. Sorry, I should have made that clear. Right there is upload and run it, because that's what you'll do on the Arduino. You can control it then. So if you wanted to, you could sit there and say, okay, I don't want it to run every 2000. I'm just going to have it blink really fast, so I'm going to go to 500. Put a parenthesis there, 500. Go down here. Try and true method of programming where you just change a little bit of code and see what it does. 500. Here we go. Upload and run. Now it's blinking quickly. Now, you got to understand, this is going to go over a web browser. So timing and sync issues, sometimes your own internet will slow it down. So sometimes looping things don't quite run absolutely accurately because of the delay in the net moving back and forth. But I wanted you to see, this is where the microcontroller gets impressive. We can be hooked on these pins. We can control this light with this pin with our code. And if we can do that, well, now I can put a sensor on there. I can put a, light detecting resistor on there, and I can, if it gets dim, I can make that light come on. If it gets dim, I can turn the light off. I can do it whatever way I want. It gives you a real power. Raise your hand if you've been able to get the LED blinking and you've been able to change it. I would also strongly encourage those people who've got the kit to physically do it. Simulations are great. It's how we do modern engineering. We simulate everything before you build anything as much as possible. But there's still something very cool about seeing the light actually go on and off. And you're talking to a person who's, been involved with a lot of robotic teams and stuff. But I still think, making lights go on is still a very cool thing. And also using an LED is a great way to demonstrate a proof of concept on the programming. All right. Kim's 7-year-old is changing code. That's what we want to see. Get them young, getting them doing it. That's what we get all our young ladies programming. All right. Okay, folks. Now, it's 9:07. All right? And this is a good stopping point because then we can go on, come back, and we can start about programming it. next Wednesday is the Thursday before Thanksgiving, and your parents would shoot me if I said, hey, let's come back Wednesday night, I'm going to guess. So why don't we shoot for the following Wednesday? Wednesday seems to be the popular time to do it. I teach a webinar from 6:30 to 7:30, so we could start our webinars a little bit earlier for people. What do people think? 2 weeks from now, and then in the beginning we might meet often. As time goes on, we'll meet less often, because what we're going to be doing is teaching you not only hardware in the beginning, but we also got to teach you the programming. But then what it begins to happen is you really start to understand the programming, and then you go much faster. By the time we get to the different sensors, you'll understand. So we've got to teach both the hardware in the beginning, then we spend a lot of time on the programming, and we get back to hardware. Since many of you have done programming, that should go pretty quick. And if you've got a team, one person can be more of the hardware specialist and one can be the software specialist. All right? And if you've done no programming, I'd scratch to teach you. All right. And Kim is telling me when we have to get by the curriculum, I'm going to guess. We have to get by before February 7th. So we're going to be meeting a lot of Wednesdays in a row to do that. All right? Also, the reason we chose Arduinos is there's tons and tons and tons of resources out there. I'm going to post this webinar. I'm going to post this on the YouTube. I will share it with everybody on here so you can sign up for YouTube. I'll get the link out to all the teachers. I'll post it on the Young Engineers of Today website. We'll get that going now that now I know which way to do it. So we're going to put this out there a couple places. There are also other places out there that have tutorials. So feel if you've got it and you're getting into it, go ahead and jump on it. All right? Now, last couple pacing things for me. So how many people can be here next 2 weeks from now? Great. We got over 80% saying. So we'll do that 2 weeks from now, and then maybe we'll wait for every Wednesday for a few weeks here to get us up to speed. And if we need to meet more than that, we'll meet more than that. All right? This is our first year, so we're going to beg a lot of patience, folks, on the best way to teach and get everybody set to go. So all I would ask is patience with us, understanding. We will try very hard to treat everybody fairly and get everybody up to speed. I'm really very excited to do this. Now, last couple things, then you can go. All right. This will help me. How was my pacing tonight? You're not going to hurt my feelings. I deal with middle schoolers all day, as well as high schoolers and little ones, and they all, and fifth and under fifth graders, they're all pretty blunt, so. All right, here we go. Let me share the results. I always share them whether too fast, 0. Too slow, 7%. Just right, 73. Well, we'll take that anytime. And then let's do this one. How well, I said need more explanation. It says science, but I got need more. It should be need more explanation. Now, the programming, I have not explained programming yet, so don't get me on that one. But all right. Okay, we're at 87%, 5, 93%, 5, 4, 3, 2, 1. And you all said okay or just right, so we'll take that. Okay. Well, folks, again, we'll post this up. I've been recording this the whole time. I'm going to post this up on YouTube for us, as well as we will probably post efficient versions, what I call efficient versions, where there is no waiting on people. I just go ahead and explain it and go on to the next one. And you can just pause the video and rewatch it. Last question on this. I said there would be no more poll questions. Really not a poll, but just raise your hand. How many people are going to take this back to school and explain it to others? That's real good for me to know. All right. I will make the PDF availables too. Links will be posted on the events resource page. Yes, Kim is absolutely right on that. So thank you for reminding me of that. So we'll get it to her. All right, we have about half of you going to pass that on. I'll get PDFs. Copyright always gets to be an issue on some of these things. As far as I'm concerned, as long as you say young engineers of today made this, I'm fine. Share it. I want to make engineers and programmers. That's been my life's work, and I want to keep doing that. So I'm happy to share it. But what I would ask is that it gets credit, okay? And, you know, obviously no one sells it or anything like that, though I don't see what the big market would be for it.